Okay, for day 4, we're going to talk about solving logarithmic equations. This is going to tie very closely to both day 2's notes, where we were dealing with the properties of logs, as well as with day 3's notes of talking about solving exponential equations. So if you have any questions there, that may filter into today as well. Just make sure to come see me at your earliest convenience so that I can help you out with that. Today with these equations, what you're going to notice is that you're going to have a variable inside your log. And that's going to look a lot of different ways, primarily 2, and we're going to talk about these cases. But for example, what this is going to look like, you might have, say, log base 2 of x equals 9, and you're going to learn how to solve that equation. You might have something more complicated that's maybe log base 2 of x plus log base 2 of x plus 4 equals log base 2 of 7. And we're going to talk about how you're going to solve these from the more simple equations to the more complicated equations here in the note. As I referenced before, you're going to have primarily 2 different types for these. So I'm going to give you 2 different sets of steps. Your first type is when you have a log equals a log in your equation. And so primarily what you're going to see is you have a log on the left side and on the right side. And so that's when you know you're going to follow these steps. Your first step is to apply any log properties necessary to rewrite the equation as log of x equals log of y. Okay, so sometimes, like in that made-up equation where you had 3 different logs floating around, we're going to have to condense our logs to look like just a log equals a log. But then what we're going to look at, and we talked about this a little bit last time when we had our common bases in our exponential equations. If I have a log of a number equals log of a number, what I know, so long as my bases are the same, which everything I'm going to give you here will be, so long as my bases are the same, I know whatever's inside the logs must be equal. So your second step is to set the insides of your logs equal and solve. What is crucial here is it had to be log equals log. One of the biggest mistakes that people make in this chapter is that they do this process right here when it's not log equals log. So if you don't have logs on both sides, that's not the type of problem you're doing here, and you can't do this process. And we will talk about how to solve that later. But if you do have log equals log, you're just going to basically drop your logs and set them equal. We do have to go a step further here and check for extraneous solutions. Extraneous solutions are when you get an answer that doesn't actually work in the math problem that you're dealing with. When we talk about logs, whatever is inside your log, which unfortunately we don't have a nice word for, must be positive. So that's what we're going to have to check. It cannot be 0, and it cannot be negative. Okay, and that goes back to kind of what we've looked at throughout the chapter. We cannot do the log of 0 because, for example, just to show you why, if I wanted you to find log base 6 of 0, what that's asking you to do is 6 to what power gives you 0? Well, that's going to be impossible. We know how to make 6 be a 1, and we know how to do a lot of different things with an exponent, but we cannot make it be 0. So this is impossible. Okay. Similarly, if I told you to do log base 6 of negative 6 even, that's me asking you 6 to what power makes it negative? Nothing we do with exponents can change the sign of your number. Okay, and so that is also impossible. So when we're checking these when we're done, and I'll show you how to do that as we go, whatever's inside your log has to be a positive number. Okay. So I'm going to start with some simple ones. We will do a wide variety of examples here as we go to hopefully hit any questions that you may have along the way. Looking at this one, again, it is important that your bases match. So those 3's are the same, which is good. anything I give you here is going to match, so I wouldn't worry too much about that. Just be aware that there is the possibility at some point in your math career that they might not, and you're going to have to see how to deal with that slightly differently. But what this lets me do, if log of some number equals log of some number, these have to be the same or the equation is just invalid. So I have to know what would make those insides be the same. You're going to solve this, and in this equation we get x equals 9. But you do have to check, and this checking I mostly do in my head. I'm going to write it out here since I'm not there to be able to talk you through it. But what you're doing is really just saying, okay, if I plug this 9 in, I would do 5 times 9 plus 9. And plugging into the other one. You don't really care what the actual number is. You would only care what the value is if you're actually checking that you did it correctly. These numbers should match so long as your math was correct. What's important is that this number is positive and so is this one when you plug it in. So what I always check in my head is I just verify it would actually be positive. You're more than welcome to type it in your calculator and get an actual value. Here 5 times 9 is 45 plus 9, that would be 54. That's positive, so that works out. On the other one, 6 times 9 is 54, also positive, so this is my answer. The fact that these are the same verifies that I did it correctly, but again, here I'm much more worried about whether or not it's positive or negative than anything else. Go ahead and try this second one. Feel free to pause the video and then play when you're ready to do an explanation. So again, with this, the logs are already condensed and set equal to each other, so I can just set the insides equal, because that's the only way that this equation will be valid. When I solve it, I'm going to add 3w, so I get 6 equals w. But we do have to actually, at least in our head, check. Again, you don't have to write it down if you don't want to, but I'm primarily concerned about what happens when I plug 6 into that log. So if I do 6 minus 3 times 6, it's going to be 6 minus 18, which gives me a negative 12. The fact that I got a negative for the inside of my log, because remember this is what would be in the log, means that this answer does not work. So if you get a negative anywhere, it's not going to work. And so here, my answer is not 6, but it is no solution. We're going to start to look at some that we actually have to condense. So looking at these, this is where I was talking about applying those properties, because here I have 2 different logs on one side and then a third one on the right side. So I need to be able to put these together, and this is where we go back to day 2 of the unit, where we talked about our log properties. Since I have 2 logs added together, I can pull them into one log so long as I multiply the insides together. So I have to do 7 times x. The right side I don't have to do anything to, so I won't. But now this problem looks like the other ones we've done, where it's a log of something equals a log of something. So we are allowed to do 7x equals 42 and x equals 6. When you check here, I would go all the way back up to the original. So do not check your condensed version, check your original. If I plug 6 into x there, that's going to be positive. And the other 2 don't even have an x, so I don't need to check them. That is my answer. I want you to go ahead and try to condense this next one. Get as far really as you can, and then go ahead and play the video to listen to the explanation. So similar to the last time, we need to condense this together since I have 2 logs on one side together. And the way that I'm going to do it on this one, when I subtract, my logs have to, or insides of my logs have to divide. Okay, we cannot cross out those x's because last chapter taught us that since there's addition on top, these don't simplify. But I can get rid of my logs and just set x plus 1 over x equal to 29. Here, to me, the easiest way to think about this is really to treat it like cross multiplying. You're going to do 1 times x plus 1, which just gives you a 1, equals 29 times x. I'm going to subtract that x over, and then x is 1 over 28. Again, you need to check. So this 1 over 28, I'm going to make sure that no matter where I plug it into in the top, it would give me a positive answer. So if I do 1 over 28 plus 1, that's definitely positive, so I'm fine. And here it's just the 1 over 28, so that's positive and it's fine. And so this is my answer. These next two are going to get us more into a quadratic equation problem, and so we're going to make sure that you remember how to do those as well. On the first one, we need to condense it. There is this 2 in front that has to be pulled into the problem. This is a log, so we can apply our log property that says this 2 comes in and becomes an exponent. Okay. And I would go ahead and actually multiply this out, remembering that you're going to have to FOIL. So I would write that twice and FOIL it all the way out to see what you're left with. Anything you're writing in the log, I would put in parentheses, because it is always assumed if it's in parentheses, it's in the log, otherwise these things would be outside of the log. But now I just get to get rid of the log since it's the same base on each side. And now we're going to go all the way back to last semester and think about how we solve a quadratic equation. And we did this a little bit last chapter as well, but we just originally did it during first semester. When you're solving a quadratic equation, remember to always set it equal to 0. So I'm going to move that forward. And then I'm going to go ahead and factor. Multiplying to 12 and adding it to 8 is going to be 6 and 2. When you factor it all the way out, you should get x plus 6 times x plus 2. When I set each of those equal to 0, because your zero product property tells you to set each factor equal to 0 and solve them individually. From the first one, I get -6, and from the second one, I get -2. You do need to check both of these, and again, go back to the original problem. If I take 6 and I plug it in for the x, it's going to be -6 plus 4, which is -2. And that we can't do. I cannot have a negative inside of my log. So -6 is not an answer. If I take -2 and do the same thing, -2 plus 4 is +2, so that is totally fine for an answer. My only answer in this equation is 2, or -2. Trying the next one, as if before, feel free to try it by yourself or just listen to me talk about it. I need to condense. They're added, so I'm going to multiply them together. It'll be x squared plus 2x, because you do have to distribute that, equals log of 3. Log equals log, so I can just drop the logs. And then again, it's a quadratic equation, so I need to set it equal to 0 and try to factor. Anything I give you is going to be factorable because I'm focusing on testing your logs, not just testing your quadratic formula. So it's a general rule of thumb. If you can't factor it, try something, check your work and see what happened. And then again, we'll set them equal to 0. And x equals -3 or +1. But again, we have to go all the way back up to the original problem and check it. If I plug the -3 in for x, that's going to be negative, so I get to cross that off. When I check the 1, plugging it in for x is positive, plugging it in here gives me 3, so 1 works in any place that x appears, so my only answer here is 1. Okay, that was type 1. Type 2 is typically the one that people struggle with a little bit more because they try to do type 1 to it and it just won't work. In type 2, you're not going to have 2 logs. In your problem, you're going to only have logs on one side of the equation. So you might have 2 on one side, but we're going to condense those and it's going to look like log equals a number. So, first rule is to apply your log properties to condense. And you may have to isolate your log. Basically, when you're done with this, you want it to be log base b of a equals x. And if it doesn't look like that, keep going until it does. With this one, our variable is going to be inside of our log, and we need to get it out of that. So the way that we're going to do it is going to go all the way back to the first day, where we are going to rewrite this in exponential form. So we are going to rewrite it as b to the x equals a. You're going to be able to evaluate that exponent value and then solve. And then last but not least, like before, you are going to have to check for extraneous solutions. As I've kind of referred to, keeping these two types straight is very important. On your test, the question types will be jumbled up. And so it's going to be important that you can look at a problem and know which type it is. And so that's what we're going to focus on while we talk about this. Okay, so on this first one, again, what I'm looking at, there is absolutely only one logarithm in this problem. I have log 5, the other side does not have a log, so that is what makes this type 2. This one is already written as a log equals a number. There's nothing else there. Like if you look at the second one real quick, this 10 we're going to have to get rid of. So this one I don't have to isolate, I don't have to condense, so I can go straight to rewriting it. As always, the base of your log becomes the base of your exponent. So it's 5 to the third equals 6x. When you rewrite it, you're going to be able to evaluate this. So 5 cubed is just 125. And then we're going to solve this. You're going to divide by 6, and x is 125 over 6. You can give me a decimal or a fraction there. That fraction doesn't simplify, so that's fine. We do need to check it. So if we take this 125 over 6 and plug it in, that is going to be positive, because if you do 6 times 125 over 6, you get 125, so that's fine. Looking at this second one, this is where we do have to work on isolating. So for example, I'm going to move this 10 over to the other side by adding it. Again, it is really important, these parentheses, because otherwise that 3 wouldn't be in there. So when you're doing these problems, pay attention to if there's parentheses or not, because they do absolutely matter. Now that this is a log equals a number, I'm going to be able to rewrite it. Your base of your log is the base of your exponent. So it's 3 to the second equals n plus 3. And then we're going to evaluate that number. 3 squared is 9. And to solve that linear equation, you just subtract the 3 and you get n equals 6. Again, do check it. So if I plug 6 in for the variable, n plus 3, or 6 plus 3 is a positive, and we're done. Okay, with these we're going to have to do some more isolating and some solving. So first off, on this one, you have two options with dealing with this -2. You can pull it in, and in log equals log problems you have to do that. But if it's a log equals a number, I can get rid of it algebraically by dividing it to the other side, and to me that's a little bit easier here. So this is going to be log base 5 of 7x equals -1. Now this looks like our log equals a number. So again, I can go ahead and rewrite it. Your base of your log is the base of your exponent, so 5 to the -1st equals 7x. If we think back about our exponent properties, 5 to the -1st tells me it's just going to be 1 over 5 equals 7x, and then I can think of this as cross multiplying. 1 times 1 is 1, 7 times 5 is 35x, and then we got to divide by that 35, so x is 1 over 35. Again, I'm going to check this up in my problem. If I do 7 times 135, that's going to be positive no matter what happens, and so my answer is correct. On this next one, we're going to have to do some condensing like on the last problems. Since I have 2 logs on the left-hand side, and again, I only want 1 per side. So I'm going to condense this, and this is going to have to multiply. So it'll be 2x squared minus 10x equals 2. Again, I just distributed that through. And then we need to rewrite it, because again, I have only 1 log, so I can't just get rid of them. There'd be nothing to get rid of on this side. When I do this, on specifically this one, I need to remember what base of the log it is when it's not written. And as a reminder, it is always a 10 if there's nothing written there. So this one's going to start with my base of 10, and it's going to be 10 squared equals 2x squared minus 10x. x. Again, I'm going to evaluate that. 10 squared is 100. And now I have a quadratic equation because of this squared term, so I need to set it equal to 0. This problem has a GCF of a 2, which could make my life a little bit easier. And then we're going to go ahead and factor. So multiplying to negative 50, adding negative 5 is negative 10 and 5. When you factor that all the way out, you should get x minus 10 times x plus 5. And then again, setting those equal to 0 and solving, you get 10 and negative 5. If you need more time to do that, pause the video. That's fine. Again, you always have to check. So if I take this 10 and plug it in for the 2x, that's going to be positive. If I take the 10 and plug it in for the x, also positive in that one, so the 10 works. If I take the negative 5 and plug it in, 2 times negative 5 does not work. So I'm going to cross that one out. My only answer is 10. These will be the last two. Again, I always like to give you plenty of videos when I'm gone. On this one, we need to isolate first, so I'm going to move. I need to get this ln of x completely by itself. So I'm going to move the 4. It's going to give me, 18 equals 3 times the ln of x. And then I need to move that 3, so I'm going to divide both sides by 3, and you get 6 equals the ln of x. Now, what trips people up about this one is remembering what your base is. Anytime it's ln, it needs to be an e. And again, the base of your log is the base of your exponent. So when I rewrite this, e to the 6th equals x. With e, you can totally leave your answer like this. You can also get it out of your calculator. So e to the 6th in your calculator, if you type that in, it's going to be 403 point, we'll call it 4. Okay, last but not least on this one off to the right. Again, I'm going to start by condensing. So this is log of 3x minus 6. If I multiply those together, again, because it is added, the base here is a 10. So it's going to be 10 squared equals 3x minus 6. 10 squared, as we already saw, is 100. And then this is what we're going to solve. So we'll add 6, divide by 3, and x is 106 over 3, or you can get a decimal for that.